So we're going to look at a mole-to-mole problem. So we're going to be going from moles of A, and that's whatever you're given in the problem. It could be a reactant, it could be a product, doesn't matter which. And we're going to be converting that to moles of something else, moles of B. So that could be anything else in your entire equation. And to do that, you need to remember when you're going from mole to mole, we're going to use the coefficients. To do this, you have to have a balanced equation. So I've supplied you with a balanced equation. Next, let's read the problem. So if 4 moles of fluorine reacts with excess cyanogen, that's C2N2. I wouldn't expect you to know that name, but that's cyanogen. Determine the moles of nitrogen trifluoride produced. So we're starting with 4 moles of fluorine, and we want to find moles of nitrogen trifluoride. So all these problems, you look at what they give you, you figure out what you want to find, and you can really ignore the rest of the problem. So to do this, we make our fence post, and what goes in the upper left? Remember, we always put what we're starting with in the upper left. And if we start with moles of fluorine goes in the bottom right. We want to find moles of nitrogen trifluoride, so that goes in the top right. And right here, this is our conversion. This is where you put the coefficients. When you're going mole to mole, you always use the coefficient. So you look at the equation. So for fluorine, the coefficient is 7. For nitrogen trifluoride, the coefficient is 2. So when we multiply this, we multiply the top, we divide by the bottom. The moles of fluorine are going to cancel out, and we're going to be left with 4 times 2 moles of nitrogen trifluoride divided by 7. So this is 8 divided by 7. I'm running out of room, but 8 divided by 7 is like 1.14 moles of nitrogen trifluoride. So it's the same setup. The key thing is when you're doing this conversion, you always use the coefficients.